the last video on sequences we looked at the sandwich theorem, and in this video we're going to look at another way we can determine if a sequence converges, and this test is called the ratio test. So let's state the ratio test and how we conduct it. If we have xn, which is a real sequence such that xn is non-zero for all n. You see why this is important in a minute. And then we suppose that the limit as n tends to infinity of the modulus of xn plus 1 over xn is equal to some real number alpha that's less than 1, then we can conclude that xn converges to 0. Right, a couple of questions you might have about this is, are you going to prove this? And the answer to that is no, I'm not going to prove that in this video, but I will try and justify it. Essentially what this is saying is, if as n gets large, the terms get smaller and smaller. So this means that if xn plus 1 over xn modulus is less than 1, then that means all the next terms are smaller than the previous terms. So if as n tends to infinity this is true, then eventually the sequence will converge to 0 intuitively, although as I say that's not a proof. But anyway, the next question you might ask is, when should we go to this test? And again, there's no real rule, but one thing to look out for is if we have some number raised to a power of n, or if we have n factorial somewhere in the expression, because this ratio will allow us to cancel out a lot of those terms, and the limit will be easy to look at. Right, so let's take a look at an example. If we have an defined by an is equal to 5 to the power of n over n factorial, we want to find out if this converges, and more precisely if it converges to 0, as we might suspect, because we've got a very large, but 5 to the power of n also gets large as n gets large, so we want to have a look at this in a bit more detail. So we're going to consider the modulus of an plus 1 over an. This is equal to the modulus of, let's start with an plus 1, so that's 5n plus 1 over n plus 1 factorial, and we're going to divide it by an, which is 5n over n factorial. And the reason I've written it in this form rather than stacking them all on top of each other is just that gets messy and quite difficult to interpret, so I'm just going to write it like this, and this is equal to 5n plus 1 over n plus 1 factorial multiplied by n factorial over 5n. We can see that 5n plus 1 is equal to 5 multiplied by 5 to the power n. N plus 1 factorial is actually n plus 1 multiplied by n factorial. Okay, so that makes sense because n factorial is equal to n multiplied by n minus 1, and multiply by n minus 2 all the way until we get to 1. So n plus 1 factorial is n plus 1 multiplied by n factorial multiplied by n minus 1 factorial, and so on. But that's just n plus 1 multiplied by n factorial. And so we're multiplying this by n factorial over 5 to the n. Now you can see the cancellations we get here. So this is just equal to the modulus of 5 over n plus 1. N's a natural number, so this is always positive. So that's equal to 5 to the n plus 1, and as n tends to infinity, this tends to 0, which is less than 1. Therefore an converges to 0 by the ratio test. And that's important whether you use the sandwich theorem, the ratio test, anything else that we look at in the future for sequences or series, which we'll get onto eventually, that you state which theorem you've used at the end. You can't just do all this working out and then just say therefore a converges to 0. You have to say that it's by the ratio test, okay? That's all we're going to look at in this video. If you do have any questions, please be sure to let me know in the comments. If I made a mistake in this calculation or I missed out a step, you didn't understand the step, just let me know. If you didn't see the last video on the sandwich theorem, please be sure to check that out, and I hope to see you in the next.